Hello, Pre Calc. This is the final review. Starfish, Captain Jack Sparrow, Can You Kill the Monster review parametric story problem. It's a lot going on here, but it's a fun problem. Let's dive right into it. Captain Jack Sparrow launched a cannonball from the Black Pearl. The cannon is on the deck of the ship, 30 meters above the water. Captain Sparrow is attempting to hit a sea monster who has just barely poked his head out of the water, 600 meters from his ship. In between the Black Pearl and the monster is a giant starfish named Evan, who Jack does not want to hit because Evan is a good guy. Evan is poking out of the water 140 meters into the air, 500 meters from the ship. Captain Jack decides on a launch angle of 45 degrees, and his cannon can shoot 80 meters per second. Letter A, write a set of parametric equations to model this problem. And what I went ahead and did before this is I came up with a picture that I think models it. So here we have the Black Pearl. I'm going to label it as such. So here we got the Black Pearl. There's a cannon on the deck of the Black Pearl. It's 30 meters above the water on the deck of the Black Pearl. He launches at a 45-degree angle at 80 meters per second. Evan the starfish, there he is right here. Evan the good guy now. He's a good guy. And he's 140 tall, 500 meters out. And then the bad sea monster. That's your bad guy. We're trying to go over Evan, arc, and hit. And there's various video games that actually ask you to do this. There was one called Tanks, and then there's one where you have these two things, and you can actually try to arc it back and forth against each other, and the first person who hits the other person wins. It's that problem with velocity, but now we're going to do the math required to solve those problems out. So kind of a fun little problem. Let's go back to our problem here. So this is a vertical motion problem. You take a cannonball, you launch it. We have a set of equations that govern vertical motion. Your x value is v sub 0 cosine theta t, initial velocity times the cosine of the angle t. And your y is equal to 1/2 the gravitational constant in meters per second. It's 9.8. T squared plus v sub 0 sine of 45t plus, I put h sub 0. Sometimes they use s, but that's your start height for your y value. So let's do the x value first. Set of parametric equations is x is going to equal v sub 0's initial velocity, it's 80. Cosine of the angle, said he launched at 45 degrees, t. That parametric right there will handle your x coordinate, or your left or right coordinate. Your up-down coordinate, y is equal to negative 1/2 g. For feet per second, your g value is 32. For meters per second, it's 9.8. So negative 1/2 of 9.8 is negative 4.9 t squared plus, initial velocity is still 80. Sine goes with y, sine is y. So we take the sine of 45t plus my initial start height, which was 30. This equation will govern left or right. Where's the ball at a certain time, the cannonball? This will govern up or down. How high up is it? How low is it? Is Captain Sparrow's first shot too long, too short, or on target? Too long, too short, or on target? Well, I don't know. The cannonball arced and hit the ground. We should find out when it hits the ground, and then we can see. So here we go. I'm going to take this equation right here. My y equals negative 4.9 t squared plus 80 sine of 45 t plus 30. And what I want to do is I want to find out when the y value, when it hits the ground. And when it hit the ground, when that y value is 0. And all of that is a quadratic that I can use Poly Root Finder to solve. So I'm going to go to my calculator. I don't actually have Poly Root Finder on that calculator, so I'm going to go to my calculator, turn it on, and I already have Poly Root Finder pulled up right there. Okay. I do want this in degrees because 45 is in degrees. So if you go down and you hit radian, hit degrees, you hit next. And I'm going to start entering values. I'm going to go negative 4.9 in for my first one. It is a plus sign, and I'm going to type in 80 times the sine of 45. Sine of 45 for that one. And it converts it to a decimal, and then I'm going to type in 30 for the last part, 30, and I'm going to click on solve. And these are the two numbers that it gives me. The negative one, it means like if I went backwards in time, if I was able to do that, if the ball now goes like this, if I was to go backwards in time, it would be 0 right there. But what this ball is, boom, comes over and lands. That happens after that many seconds. So 12.05, and I'm going to be pretty accurate, 12.053 seconds. So my t value of 12.053 seconds, it hits the ground. I wonder how far it went. Is there an equation that tells me how far over it went? Well, I don't know. Let's see. We have my x equation here. That will tell me my left or right value. All I have to do is take 80 cosine of 45 and plug in 12.053 for my time, and I can find out the left or right value of this. So I'm going to go to my calculator, and this is just completely plug and chug. I'm going to quit out of Poly Root Finder, and I'm going to type in 80. Let's make sure my mode's right. My mode is in degrees, that's right. 80 cosine of 45 times 12.053. And out of that, I got 681.8. I got an x value of 681.8, and that would be in meters. So here's what I just found out. When the y value is 0, the time that it hits the ground is 12.053, and it went 681.8 meters. So it takes 12.1 seconds, 12 point whatever that was, to go 680. Oh, Evan was out 600. It went to 681. Too short, or he went too long. So let's go back to our sheet here. Too long, too short, or on target. He shot way too long. Too long. All right, letter C. Find the maximum height of the cannonball and the time it takes to get there. Maximum height of the cannonball, that's an up-down. That is my y equation. My y equation is right here. Y equals negative 4.9 t squared plus 80 sine of 45t plus 30. Y governs how high you are. Well, I want to find the vertex because it's an upside down parabola. That maximum height is your vertex, and we've been doing that negative b over 2a and then plug it in. So I'm going to take negative 80 sine of 45 all over 2 times my a value, and my a value is negative 4.9. Negative b all over 2 times a. Press pause, do that on your calculator. All right, when I did it, I got 5.77 seconds. And now what do I do with that value? I know how long it takes to get up there, but I don't know how high it went yet. Well, what I would do is I would take that time, and I take it and I plug it back in for the t values. So I'll take negative 4.9 times 5.77 squared plus 80 sine 45 times 5.77 plus 30 is the max height. Press pause and do that. I got 193.27 meters. So here's what I now know. In 5.7 seconds, the ball hits its max height. and that max height is 193.27 meters. Okay. Next one. Does Captain Sparrow miss Evan with his first shot? Is he going to hit Evan? So I know it went up 193, so Evan's only 140, but does it go boom, clip him? Does it just go boom and clip him? Or did he actually make it over Evan with his first shot? Well, I wish I knew how long it took to get the 500 meters. That's an X value, right? Oh, geez. So let's figure that out. Let's figure out how long the ball takes to get to Evan. So that would be the X equation, my left or right equation. So I'm going to take the X equation and I'm going to set it equal to 500. 80 cosine of 45t. And that'll tell us how long that ball is traveling before, if we find that t value, it'll tell us how long that ball is traveling before it gets to our starfish. So take 500 and divide it by 80 times the cosine of 45, and you're going to find a t value. Press pause and do that. I got a time of 8.839. 8.839 seconds is how long it takes for that cannonball to get to Evan. How high up is that cannonball when it gets there? Well, I can take that and I can do the exact same thing I just did here. I can take that time and I can plug it in. So that part of the equation would be negative 4.9 times 8.839 squared plus 80 times the sine of 45 times the 8.839 plus 30. Got a little scrunched over there, but this is one line. And it's a matter of plugging it in on your calculator. Hit pause. See if you can figure out if it missed Evan. And I got it, yes, it missed. And what I got when I did it is I got, does Captain miss Evan? I got 147.71. At this, I got 147 meters about. So we could conclude that the cannonball missed Evan by about 7 meters. So almost gave him a flat top. Okay. At what speed does the first cannonball strike the water? Oh my goodness, at what speed? Now what we're going to get into is we're going to get into the calculus. And speed is an instantaneous rate of change for us. So the first thing that we need to do is we need to go ahead and we need to find the derivative of these things. So I'm going to take this and I'm going to show you a shortcut to the derivative here. This is the first time I've shown you this. You might have noticed this as you went through it, but there's an equation that x equals, it was v sub 0 cosine theta t, v sub 0 cosine theta t, and then the other one was y equals negative 4.9 t squared plus 80 sine 45t plus 30. And this is really a preview of things to come for you for calculus, because when you do calculus, that whole derivative formula, you're not actually going to have to do all that. Calculus is about the shortcuts to finding derivatives. And the rule for a polynomial equation is simply this. You take the degree of your variable. So I want the derivative with respect to time. You take your exponent, that's t to the first, okay? My initial velocity was, let's find it, 80 cosine 45t, so 80 cosine 45t. My initial velocity was that, so what you do with that exponent is you pull it, you take it and you pull it out in front, and you multiply whatever's in front by it, So 1 times 80 cosine 45 is 80 cosine 45. And then you take the exponent and you drop it by 1. So it becomes t to the 0 power, or it just becomes 80 cosine 45. All right, let's apply this shortcut here. Okay, I take that exponent and I drop it out in front and I multiply. So 2 times 4.9 is negative 9.8. I take that exponent and I drop it by 1, t. So this component, multiply, drop it by 1, plus it's t to the first. I take it, I pull it out in front, and I multiply. It becomes 80 sine of 45. And that becomes t to the 0. I drop it by 1, and that would just become nothing. It become t to the 0. I'll put t to the 0. And this one is t to the 0. So I'll take the 0, I'll pull it out in front. It's 0. If I have a constant there, think about it now, t to the 0. Let's take 0 out in front, and then 0 times, even if that was t to the negative first, the constant values, they wipe each other out, and I get y equals negative 9.8 t plus 80 sine 45. And that's a shortcut for the derivative, and if that doesn't get you excited about calculus, I don't know what will, because calculus is the math of shortcutting all of that limit math that we just did. Oh my goodness, that is awesome. So I'm going to do these two problems now. At what speed does a cannonball strike the water? So we have the cannonball's coming down like this, and I'm going to draw two separate things here. So there's a right angle there. I'm going to think about the x component and the y component two ways. Okay. The first one is like a speed, like how fast is it really going? Well, I know the x component is 80 times the cosine of 45. So this value down here is 80 cosine of 45. And I'm just going to type that in, 80 cosine of 45. And what I get out of that is I get 56.56. 56.56 right here. 56.56. That's how fast horizontally it's traveling. How fast vertically it's dropping is, well, it's actually speeding up as it's going down. I wonder how fast it's going at that spot. Well, I have a derivative formula, and I know when it gets there. See, I know my time when it hit the ground. My time when it hit the ground was 12.053, and I know I have an equation that tells me how fast it's going when it gets there. So that little chunk right there, that little chunk will be negative 9.8 times 12.053 plus 80 sine of 45. I'm going to do that on my calculator. So I'm going to go negative 9.8 times 12.053 plus 80 sine of 45. And I got 61.55 negative. Negative 61.55. Oh, and that makes sense. It's going down. It's going down. So, look at this little triangle here. I know its horizontal component is 56.56. I know the vertical component is negative 61.55. I'm going to repopulate my triangle over here, 61.55, a second one, and 56.56. And there's two things I want to figure out. I want to figure out this speed. I'm going to call it x. And I want to find out at what angle does it strike the water. I want to know that theta. Because not only from this information can I tell how fast it's going, I can tell the angle that it's going to hit the target with. And holy cow, this is just like tank math. If you were at a tank, you would need to know the calculus required to launch your item, launch your ordnance, your cannonball. So how do you think now I'm going to get to these two answers? Well, at this point it becomes easy math. It's a Pythagorean theorem problem. Negative 61.55, all of that squared, the negative will drop out, plus 56.56 squared equals my x squared, You'll solve that out for your x. And then here, it's a tangent problem. And I don't really need the negative sign. I just care about the number. So I take the tangent of theta is equal to opposite 61.55 divided by adjacent 56.56. And I come up with the two answers. My theta value is whatever I would get when I hit theta, the negative tangent to the negative 1 of that. The two answers I got 83.6 meters per second. And my other one, it's coming in at a 47.4 degree angle. And I just used calculus to figure out how fast that cannonball was going and where it hit at. Let's look at our calculator now. Let's see if our calculator verifies it. I went ahead and I plugged in 80 cosine 45t and negative 4.9 t squared plus 80 sine. I typed the whole thing in. Plus 80 sine 45t plus 30. I'm going to go to my window and I'm going to step it off at 0.10. 0.10. And I'm going to watch the trip of this cannonball now. So let's hit the graph button. And there's my cannonball. By the way, when I did this, I also set my window up. I started my window at 0, 12, T-min 0, T-max 12, T-step 0.1. Don't forget your mode is in parametric and simultaneous. I was in degrees, so back to my window. From 0 to 12 on my max, I stepped it off by 0.1. My X-min was 0, my X-max was 700, my X-scale was 1. Y-min 0, Y-max 300, Y-scale 1. So you can see all of those. And here's my picture. Okay, so let's trace 0. It should be up 30 feet. At a time of 0, I'm at 30 feet. Y height, my X value is 0. Let's trace the vertex, which I think was 5.77. And I hit enter, and at 5.77, it went up 193 feet. That was what we found, about 193.3 feet high. Let's trace the time. It was going, let me see here. Trace the time of 8.839. We'll just go 8.8 seconds. We'll figure out how high it was at Evan. So I'll trace 8.8 seconds. At 8.8 seconds, it's almost at 500. Maybe I cursor over 503. And you can see the like 147 is what I got if I would have typed it in better. And he missed Evan. And now let's trace the last one. And the last one was when it hit the ground. And he hit the ground after 12.053 seconds. So we'll trace 12.053. Enter. Oops. Oh, it's after 12. Oh, I set my window up from 0 to 12. So I'm going to T-max it at 13. Enter. I'll go back to my graph. It wouldn't trace it because my window was outside of the range that I was trying to trace. So there it is. And now I'm going to trace 12.053. And I can see that barely, basically, is on the water. And he's at 681.82. Now, what I usually have people do at this point, and you can try this if you want, is can you modify your equation so that you miss Evan and hit the monster? Okay? And what I would want you to do is you can slow the ball down by using less powder, or you can change the angle, but you can't speed it up. So 80 is the most that you can have here and here, but you could mess around with this 45 and see if you can get that cannonball to launch over the top of Evan and plop it down. I give you a hint. I usually just leave the velocity alone. And I know that ball went too far. I would just try to maybe increase that angle and see if you can get it to come up and come down, plop right on Evan. And that's what you look at. That's what you try to do. The last thing I want to do, let's go to calc. Let's find the dy dt value. And that's the derivative of y with respect to t. And where I want to do it is at a time of 12.5.053. And I notice the dy dt, which would stand for the instantaneous rate of change of y with respect to time, with respect to t, was negative 61.55. Look at that. So that actually supports what we have. So I'm going to second calculate again. And this time I'm going to calculate the derivative of x with respect to t. And I'm going to type in again 12.053. And I got 56.56. 56.56 for the derivative there also. Okay? Wow, what a great problem. A lot here. A lot I wish we were in person for. But you can pause this video. You can go back and look at it and use some of the techniques that I used to solve this for other problems involving vertical motion. All right, good luck.